Okay, in this video, we are going to talk about the standard normal probability distribution, z-scores, and how to find a z-score using Excel and the STANDARDIZE formula. So the normal probability distribution is simply a probability distribution with a mean of 0 and a standard deviation of 1. So here we can see a picture of that. The mean is 0, the standard deviation is 1. So if I move over here 1 unit, that is 1 standard deviation. I move over 2, that is 2 standard deviations. I go 1 more, that's 3 standard deviations. If I move to the left, 1 standard deviation to the left, you can see is marked here with a -1. 2 standard deviations to the left is marked with a -2. 3 standard deviations to the left is marked with a -3. These values, instead of x's, which we usually use for a random variable, for a standard normal, we're going to use z for the random variable, where z is the z-score. And as we can see here, if these are considered z's or z-scores, they represent the number of standard deviations that one is from the mean. So the standard normal probability distribution has a random variable referred to as z rather than x, and so it's often referred to as the z distribution. I showed you that a z-score is the number of standard deviations that a score is from the mean. So if you have a non-standard normal and you want to compute the z-score, you first need to find the difference between that score and the mean. And here we always do the subtraction score minus mean. This will give you the distance from the mean. And if it is negative, it's because x is smaller than the mean. And if it's positive, it's because x is bigger than the mean. So this will give you the distance from the mean. And then when we divide it by the standard deviation, it tells us the number of standard deviations from the mean. So here's the formula for a z-score. X minus the mean, that difference divided by the standard deviation. And Excel, instead of doing this computation, you can use the formula STANDARDIZE. When you hear the phrase standardize a score, it simply means you're finding its equivalent z-score. So you're finding how many standard deviations that score is from the mean. So we standardize by telling Excel the score we want to standardize and the mean and standard deviation of the non-standard normal so that it can then do this computation for us. So let's see how that works. Let's find the z-score for 69 inches. This here is for the distribution of men's heights with a mean of 69 inches and a standard deviation of 2.8 inches. Now, since the mean is 69, this is right in the middle. So notice if you were put it in the score, 69 minus the mean of 69 gives you 0. Right? Because the mean of the standard normal is 0, so the mean of a non-standard normal will then have a z-score of 0. We'll find that when we put it into the formula standardize and we tell it the score is 69 and the mean is 69, standard deviation is 2.8, and there we go, we have a z-score of 0. 65 inches, notice, is smaller than the mean. So when we standardize this score, it will be negative. So 65, 69, 2.8, close the parenthesis, and we see we get a negative 1.428. This tells us that the score of 65 inches is 1.428 standard deviations less than the mean because it's negative. 75 inches is bigger than the mean of 69 inches, so this will have a positive z-score. Equals standardize 75, 69 for the mean, comma, 2.8 for the standard deviation, and we get 2.14. So this score here is 2.14 standard deviations away from the mean, and it's greater than the mean. So we say it's 2.14 standard deviations above the mean, whereas the 65 inches had a z-score of negative 1.428. We could say that this is 1.428 standard deviations below the mean. 60 inches is also smaller than the mean, so this will also have a negative z-score because it is below the mean. So we go equal standardize 60, comma 69, comma 2.8, close the parentheses, negative 3.21. Negative 3, this is 3.21 standard deviations below the mean. Finally, let's do the 70 inches, standardize 70, comma 69, comma 2.8, close parentheses, boom, and we have 70. Notice that's only 1 inch away. That is only 0.357 standard deviations away from the mean. Okay, so this is all fine. What does that tell us? Let's look a little bit more about normal probability distributions and how it relates to the standard normal and z-scores. Here's something called the empirical rule for standard normal probability distributions. 68% of the scores are within 1 standard deviation of the mean. 95% of the scores are within 2 standard deviations of the mean. And 99.7% of the scores are within 3 standard deviations of the mean. Let's go back and look at our graph here. All right, so here is our mean, right here at 0, z-score, 0, there's the mean. 1 standard deviation away from the mean to the left takes us to negative 1. 1 standard deviation away from the mean to the right takes us to positive 1, so that this distance here, it's 2 standard deviations wide, but we say it's within 1 standard deviation of the mean. So everything in here is within one standard deviation of the mean. Okay, so everything in here is within 1 standard deviation of the mean, all this stuff in here. All right, turns out that that is 68% of the data. Okay, so all in here, we have 68% of the data is within 1 standard deviation of the mean. Okay, well, how about 2 standard deviations from the mean? So over here, negative 2, 1 standard deviation to the left. Over here at positive 2, 1 standard deviation to the right. Notice here, we're actually looking at 4 standard deviations. But we say we are within 2 standard deviations of the mean. Notice how when you look at this whole curve, that is most. That looks like most of the data. All we're missing is a little bit here in the tails, right? A little bit here, a little bit here. It turns out that everything in the middle here, all of this, that is 95% of the data. So 95% of the data is within 2 standard deviations of the mean. Okay? 95% of the data is within 2 standard deviations of the mean. All right, so that means that there is 5% left divided equally into each of these 2 tails. So each of these tails has 2.5%. We have the bottom 2.5% on the left. We have the top 2.5% on the right. Now, this is actually really important because we're going to be talking a lot about the middle 95% of the data, right? So the middle 95% of the data is within 2 standard deviations of the mean, so that you have 2.5% left split into either tail. We will see this a lot in the course. You hear about this a lot in statistics. The middle 95%, the bottom 2.5%, the top 2.5%. Finally, let's look at 3 standard deviations from the mean. Okay, so remember, here's the mean. So 1, 2, 3 standard deviations is way out here. It's the end of where I drew the curve, but theoretically this curve keeps going on forever, just gets closer and closer to that horizontal axis. Moving to the right, we're at 1, 2, and then here's 3 standard deviations way over here. There is virtually nothing left out in the tails. So how much is in here? You can see it's almost everything. It turns out that this here is 99.7% of the data. 99.7% of the data. Virtually everything. So most of the data is within 3 standard deviations of the mean. Okay, so what do we know then about data that is more than 2 standard deviations away, or even more than 3 standard deviations away? Data that is more than 2 standard deviations away from the mean is considered unusual, or you can even just say unlikely. So here, when we're in the tails, the 2.5% in the tails, those are the unusual scores or the unlikely scores. Okay, that implies then that the middle 99.7% are the usual or likely scores. And that's important to remember. The middle 95% are considered the likely values or the usual values. The bottom 2.5 and the top 2.5 are considered unlikely or unusual. Well, then what about being in the beyond that? What about being here beyond the 3 standard deviations from the mean? What's going on there? Well, those are so far out that it's way beyond most of the data that we refer to these as outliers. So anything more than 3 standard deviations from the mean are considered outliers. Let's now go back and look. Let's go back and look at the problems we were doing earlier over here when it says, which of the above z-scores denote unusual scores and which denote outliers? So if we go over here, we see that this score here, the one that is more than 2 standard deviations from the mean, that score for 75 inches, that is considered an unusual score. This score here, that's also more than 2 standard deviations from the mean, so that's also considered unusual. So both of these are unusual. Furthermore, this one here, the negative 3.21, that's more than 3 standard deviations from the mean, so that is even an outlier. That is an outlier. So it's important to remember that if you're more than 2 standard deviations from the mean, or if a score is more than 2 standard deviations from the mean, it is considered unusual or unlikely. If it is more than 3 standard deviations from the mean, not only is it unusual and unlikely, it's considered an outlier. Okay, so I hope that helps explain a little bit more about z-scores, what is considered likely or unlikely, the 68, 95, 97, 99.7 rule, which is referred to as the empirical rule, and how all that relates to a graph. Thank you for watching.